Hello everyone, this is Bradley. So today this is a voice recording to make this smoking trail like animation, which I've done in the past without simulation, which means it was very limited because of the speed and other things. So today let's try with simulation methods. So let's start. So here in Blender, as always, I'm going to use the presets, which you can download for free from the link in the description. Because I need to hurry going outside, so I probably have only limited time to make this tutorial. Let's start with a procedural grid. And I can use anything to really trigger this animation. So let's start with an empty. Okay, I have an empty, and I think this will be fine. Just use an empty to trigger it. So I'm going to add a kind of fold, proximity fold, so that if I select this empty object, you can see closer to the center the whiteness it will give. If you increase the bump, then it becomes more accurate. So this is the idea. And we're going to construct a concept called a memory fold, which is basically just a trail or dynamic painting that you will have. So we add this fold and we add this. So we newly evaluate a fold and we add this fold with the fold from last frame. Then what you will see is that you can see there is a trail being generated. You can paint such kind of stuff. Let's increase the duration of this entire animation so that we can see everything. So now you have this kind of trail, but of course this trail contains a kind of limitation that it does not disappear. So to make it disappear, what you can do is to multiply a value. So what you left previously will decrease over time, and you can change these parameters. Okay. This concept of memory fold is very important because you can do the transition of materials, or you can instance your object using this fold. You can deform the plane using this fold. This is actually one of the most common usage of simulation nodes because you can really paint something onto this ground. But today we're going to do that differently because I'm not leaving this trail. I'm just going to generate the geometry using the most basic fold. So let's just delete that. What I'm going to do, however, is I'm going to create a geometry output instead using this instance on point. I can join them together inside the simulation zone, but I'd like to join them outside because I want geometry, which means actually a mesh in this case, because it's a plane, to be separated from our instance. You can join them together, but it also means that you have to separate components afterwards. So up to you, whichever one you like. Okay, I think it becomes a little bit clear that instances are instances and mesh are mesh. Okay, so now I'm going to instance an icosphere based on this fold. So let's take an icosphere. So now actually you can see how it goes. Let's turn this radius to be 0.01, something like this. So we have small balls, and you can see I'm actually painting balls because I'm only selecting certain areas of a mesh to instance my balls over time. Okay. Right now, this is pretty slow, or actually it's fast, but you need to understand that this is a very dense grid, and we are instancing on every of these points. So I'm going to use point distribute. There's a point distribute on face. But the downside of this node is that you cannot control the amount, you are controlling the density, which means that if you're increasing the size of your plane or decrease the size, it actually becomes having more points which is very annoying because it may crash your computer due to too many amount of instances. So here I'm going to use a preset which is called point distribute, in which you can basically control the amount of points. Actually, it's kind of limited. Okay, so this is the concept. And to do that, we'll just replace it. And let's set the 15 points for the moment. And then now if I play this animation, you can see it's not going because I need to set the selection. Okay, yes. Now I realize our icosaphy is a little bit too tiny. So let's just, so now we are painting balls again, but this amount is not as much as previously we had. Here you may notice that if I change the parameter of my icosaphy, it does not lively update the setup in the scene, because this is a simulation. You have to play the animation to visualize your changes. Otherwise, everything is actually driven by the cache in the timeline. To make our life a little bit easier, you can only join the points and you instance afterwards, so that I can control this radius. Okay, so this is also a way. There is no right or wrong, whichever way to do, but you realize it becomes a little bit more convenient if you can see how much scale you actually have in the viewport. Okay. Next, let's generate some important attributes for our particles. Let's start with a store named attribute. What you can also do is you can add a kind of linkages into the simulation output, so that just like geometry, this any linkages will actually go back to the simulation input. But I prefer store named attribute in this particular case because I'm drawing geometry, so that I want to make sure that my values actually comes from this specific status. Okay, otherwise I will confuse myself. So I give a scene time and it will be frame. And let's just name that as a time. So I'm recording the time for these points to be generated. So this is actually the burst time of my particles. Okay, and this burst time is very important because if I use the current time to subtract our burst time, so take the named attribute t, then it means I will have an age. Okay, your birth at 1993, and right now this is 2023, so you know your ages. Okay, so we take a map range and let's give it 15 frames of life, and let's take a remap 0 to 1. Because I may use this Falloff in many different cases, so I'm rather to use the remap 0 to 1, so that I can keep the initial value of this 0 to 1. But you can see actually this is the effect. You realize this is very similar to the memory Falloff result we had previously. That's why I said memory Falloff is kind of important, despite the fact that we are using a different approach to achieve the similar result. Okay. Previously we were using multiply to subtract the value, but right now we're using map range to deal with the ages. Next, let's add some movement to these particles. Since we're doing kind of a trailing animation, it means we need to make the movement of particles relative to the position of my empty. Okay, and to do that, it's possible that we use the existing simulation zone to record the object info of my empty object. So you take the relative and you input the location to the output, so that this output will feed back the location to give the previous location. And by subtracting current location with the previous location, you get the velocity. So you get a kind of idea. But here, let's try with another preset, which is called the temporal object info. This is kind of interesting because it contains a simulation zone, just like what I described earlier. So I want to see if a simulation zone can actually work inside another simulation zone. Let's try. So let's put a store named attribute because we need to store the state of velocity. So let's take a vector and let's name that as a velocity. And I take this velocity, select the object. Okay. And this velocity should be -1. And you can do the animation inside or outside the simulation zone. So for now, let's do that inside the simulation zone. So I take a set position and I use the named attribute. I have attribute v to offset it. So now if I play this animation, you can see they're actually flying in the opposite direction and disappear. So let's increase the length. Here I want you to be aware that this velocity is kind of constant. It does not have a moment to slow down. It will always be this fast. Okay. So what can we do if you want to slow it down? Then you need to redefine the velocity. So you store a new velocity. So every time this old velocity will be scaled to be 0.8. And I use this new updated velocity to offset it. This node tree may look kind of very confusing, but you need to understand that even if linkage come from the same socket, the data actually derived from the green socket. So this node by itself has no meaning. So in this case, that this linkage, or actually this linkage is about 80% of this linkage, okay? Because we redefined at this particular moment. If you do not really understand this kind of logic behind, then you can just take another named attribute so that it may make you feel a little bit better. Oh, these two are different nodes. Perhaps, I don't know. But anyway, so now if I play this animation and I move my object, then you can see originally they move very fast, but soon they stop due to this 80% of decay over time. And you can try to keep this value as high as possible, maybe 91%, or maybe you make it very slow, then you can see it almost has no movement. It feels like this empty is vomiting something on the ground, but anyway, so you get a kind of idea. There is, however, an alternative method that you do this setup outside the simulation zone. So that's right now, let's disable this store named attribute and set position. If you only set position outside the simulation zone, it means this node will only be operated once instead of as many times as you play the animation. It means that basically you have no animation here. Okay, you see there is no movement even if you input this velocity. However, what you can do is that previously we have an edge, and this edge obviously is constructed from the time which is active when you are playing this animation. So we basically do the same. Let's get a new map range and new remap 0 to 1, and we scale this velocity. Let's keep that as 0 to 1, so no reverse. And by plugging this result into the scale, you can actually see something what's happening in the viewport, and you increase the scale. Then you can see all these kind of changes are procedural, and you can see them in the real time, even without playing the animation. And then when you play this animation, you can see that you have a start and you have a stop. Okay, let's make these two scale different. So now you can actually see there is a start and a stop of movement. Okay, so I personally prefer doing everything outside the simulation zone because I feel you have more control over it, especially I do not keep playing the animation in order to visualize the changes. Okay, so this is the parameter things. And here, what you can do is you can even use the same fold, so that you can use the same time to control both the scaling and the movement. When they stop, they disappear. That's why I use this remap 0 to 1, so that you can remap this 0 to 1 differently. Another important thing that this is a linear function, because this is a linear remap. If you put a float curve, it means you can interpolate these two values, just like when you're keyframing, you are working with graph editor. Okay, so this is a kind of keyframe at the birth of my particles and at the end of my particles. Okay, and you remap this relationship. So maybe you can try by yourself, but it's like okay, actually I interpolated too much, so let's go to the other extreme. So there was a sudden decrease of my particles, because that's how I interpolated that. So this is kind of important when you're trying to play with this velocity, I think. So you shoot very fast, but it's just like whatever. I don't think it's realistic. Let's delete that. Parameter thing you can deal with by yourself, but basically this is the concept. After explaining these concepts, let's move on to make our animation. So I'm going to delete what's inside the simulation zone, because we are animating that outside. This is the method I prefer. And then we can add some vector, so that it does not just fly on the ground, but there is a kind of elevation. So we can combine x, y, z, and it should be -1, or actually +1. But anyway, so we can add the length of this combine x, y, z, so that it always fly at a 45 degree to its previous direction. So now this is how it goes. Of course, you can change the ratio of it. And next is that currently we're stop this animation using this scale. If I do not set the scale down, you can see these particles will stay. Okay, so here I'm going to use a different method to delete this geometry. Of course, I probably still want to scale them down, so let's take that 0.2. But I want to give a different smoke disappearing animation to it. So the way I'm doing that is I'm using delete geometry, which means I need to access these points by realized instances. Okay, and I need to store eevee map. So let's take this eevee map into it. Originally, this node is designed to export, which is basically store named attribute, to shader. But here we are going to use that differently. I'm going to use a delete geometry. If I put delete geometry, by default, it's deleting everything. But if I use a noise texture, by default, this noise texture is using the position vector in geometrynodes. But here we're using named attribute eevee we created earlier. So eevee map at face corner domain. So if I plug this factor into selection, because this noise texture is always outputting something bigger than 0, which means deleting everything, we can use an addition function to create a kind of fold. So that you can see there is a appearing and a disappearing effect by manipulating this value. Okay, this is very important because we are going to get this addition done. Previously, we have this remap 0 to 1 fold, so we just duplicate that. And this time, maybe you already realized it's from -1 to 0. So I plug that in. So now, if I play this animation, then you can see that there's kind of a smoky disappearing effect. But you also realize that they are the same disappearance. So what you can do is that you can rotate this icosphere differently. Or there's another method in which you add a different random seed for your noise texture. By the way, this is a UV map is 2D, so we use that 2D, so it will improve the performance a little bit. Another thing is that I can take a vector seed, and you can use mesh island to this seed. So island index is a way to do. So it seems working fine. So I will just keep with this island index, because I was expecting some issue with this island index. If there's any issue, then you just use instance index instead by plugging attribute instance. But it seems working, so I'll just stay with it. Okay. But now if I stay with my empty, then you can see that they are not disappearing. Actually, they are disappearing. The only issue is that I'm generating the same points at the same location all the time. So even if some parts is disappearing, but other parts, the new generated sphere is covering the disappeared one. And it actually makes your computer heavier and heavier because I'm always generating billions of particles at the same location. It comes to actually a question that when my point is not moving, then obviously there should not be any particles being generated. To solve that problem, it should be quite easy that when the velocity is 0, then these particles should not be generated. So let's add a new rule. We generate the particles not only if this proximity Falloff is on, but also when this velocity is on. So we take this length and plug that into the boolean. So right now, if my empty stays at the position, we have no particles. But if I move it, then these particles will be generated. Okay. And if my empty is not close to the ground, then no particles will be generated as well. And you can see the performance is very nice because we're not generating anything. And when it touches, you have this tiny smoky effect, which is very nice. Obviously, you can tweak all these kind of velocity settings because it really depends on what you're trying to do. Okay, and finally, let's just finish this animation because currently we're driving everything is using an empty. So let's make a cube and let's join geometry. And we can parent this cube with our empty. So now we have a cube being done. Let's increase the size a little bit. Or maybe you do not really care. Let's use a single value to control 3 axes. So 1.5, something like that. And then let's just control my empties. Let's play this animation and control my empties. Yay, I have it. So this is it. The rest is about shading problems, you add the materials, but now you have it. Of course, what you can also do is to change the direction of your cube based on its movement. That's why I used an empty, because you can do the direction afterwards. But that's not the topic today, so I do not want to cover it. This tutorial is already quite long, so I hope you enjoyed this video. I'll probably see you next time. Bye bye.